Oh, I just because a few people have been asking about it. It's just a quick, brief video on the progress of the doorbell. I'm happy with the prototyping, so I'm just about to put it to bed now. Um, the doorbell, it's going to be yeah, it's going to be a doorbell, but it's not just going to react to the push button by the front door. It's going to react to a few things around the house and sort of be a central communicative notification device. Let's just say, it'll sound off when there's someone at the door, but it'll also sound off in a different way if, let's say, the washing machine's done or the oven timer is expired. So it's not going to be an intelligent doorbell per se, which is I think what I've been calling it, but it's going to offer a bit more communication than whether or not there's someone at the door. But for the time being, it's working as a doorbell and only a doorbell until I get a few more peripherals made to transmit data. So anyway, there's two parts to it. Like with any doorbell, there's the transmitter, which I've got here, and the receiver, which I'm basing it around the 80 Mega 328, which is currently mounted on the development board, an Arduino Uno. The receiver itself is this little 433 megahertz AM simplex device. For prototyping's sake, I've just got the red LED there mounted to the outputs, just so I can see that it's receiving a signal. And the white LED is just to symbolise the doorbell itself. So if I transmit a signal with the transmitter, you can see it. You can see the output of the receiver pulsating, and the microcontroller is counting the pulses in a very particular sort of way. So I'll stop the pulses now, and after a quick calculation, the doorbell sounds off. So its behavioural characteristics are pretty simple. Someone presses the doorbell, and then it sounds off. So like I say, I'm pretty happy with the prototyping. So this is about to be made up and installed. So, if anyone's interested, this is a quick and dirty connection diagram of the transmitter. But it's based around the 555 timer, which, if anyone's ever done anything with electronics, the old analog ICs like the 555 are probably where you started out. But you know what? They're still quite useful. And in this case, this one's producing a square wave with a wavelength of about 30 microseconds. The the microcontroller is programmed just to look for that particular wavelength and to react upon only that, because the radio receiver has been picking up some noise or some unwanted signals. I'm not sure if someone around here has a heating thermostat that's working on the same frequency, but every now and then I've noticed this LED will give about 3 pulses. Ah, there we go, actually. Perfect timing. Those 3 pulses there. I don't know what that's being transmitted by, but it's not in this house anywhere. So regardless of what's transmitting it, I need to teach the microcontroller to ignore it. So that was the most time-consuming bit, really, in encoding the transmitter with a very particular signal, and encoding the micro to look for only that signal. Anyway, yeah, like I said, I'm done with the prototyping. If you want to have a look at the schematics for the transmitter and the receiver, I'll post them up somewhere so you can take a closer look, and I'll stick a brief description on how it works as well. One more thing, the transmitter here, like I say, it's 433 megahertz. I've got a few more of these things. They're literally quite almost to a penny, and so the next thing I do is going to be stick another transmitter like that in, I don't know, let's say an oven timer, or a device that will tell me the the washing machine's finished, because I hate trying to guess when it's done. And I think transmitting a signal to the doorbell would be a good way, because the doorbell's pretty central in the house. You can hear it everywhere from in the house. Whereas if there was an audible device actually on the washing machine, it's got to get through several walls and doors before we can hear it in the living room. Whereas the doorbell, it's just right outside the living room door. So the first thing I'm going to do is start getting this on a bit of PCB, well, a bit of breadboard, and mount it in a push button enclosure, which I've got one here. It's big. That's because it's an industrial type push button enclosure. It's weatherproof. It's IP65, I think, IP66 maybe. I'm not sure, but it's weatherproof, so that's all that matters. Single push button, and it can be backlit. Inside, you've got the normally open contact there, and an LED, which this one's white, and preferably I'd like a green one. So what I'm going to have to do is hack it as well, because these industrial components are designed to work on 24 volts. For example, if you stick a 24 volt supply through the LED module, it'll light the LED. But here I'm working on 6 volts, which is not going to be enough. So I'm going to have to hack one of these just to get it to work off 6 volts, which shouldn't be too hard. I've actually already begun to do that. I've got one of these LED modules here, and break it open. You've got a full wave bridge rectifier in there, that basically so that you can connect positive and negative any way around you want, and the LED will still work. What I'm going to do is basically just swap out the resistors for the correct values, and because, like I say, it's a white LED and I want a green one, I'm going to have to swap out the LED as well. Again, not too much of a big deal. So hopefully next time I update, it'll all be in this enclosure, and I'll be halfway towards getting the receiver and the microcontroller on a PCB, so as to finally getting this thing put to bed, because it's a simple thing and it's taking way too long.